So here is the lecture on the types of transmission lines. So the conventional open wire transmission lines are not suitable for microwave transmission. Why? Because they have radiation losses, and the radiation losses are high. At the microwave frequencies, the transmission lines employed can be broadly classified into three types. First of all, it is multi-conductor lines. It's multi-conductor lines. Secondly, it is a single conductor lines. That means that basically it is divided on the conductor itself. And third, last but not the least, that is the open boundary structures. So basically there are the three types of structures right there. So if you say what are the microconductor lines, what are really the microconductor lines? Microconductor line means they have multiple conductors inside their structure. As you can say, for an example of a coaxial cable, coaxial cable has two lines. One is the internal conductor and the external conductors are on the other side with a cladding jacket. The cladding jacket is made on the plastic core. Okay, just like this. They have a core with the conductor that has been made through the metal conductors. So there are two type of metal conductors. The high transmission should have to be made by the central core conductor, which is made by copper, which has high conductivity, and the other conductors which have the lower conductivity has been rolled with a certain wiring system, or we can say by meshing or making things like a net that has been attached to the coaxial cable. And the two conductors are separated by a dielectric. Okay, dielectric material. They can be plastic, they can be polystyrene material, any kind of material like this. Okay, so these are the coaxial lines. Another line is that the strip lines. They are also the multi-conductor lines. The microstrip lines, the slot lines, we will know further when we will go through to this. And there are coplanar lines. So these type of lines are multi-conductor lines. So what are the single conductor lines? The single conductor lines, we will discuss about the single conductor line on the separate lecture on waveguides. They are known as the waveguides. In waveguides, there is a hollow channel. There is no other dielectric used here, just a hollow channel. That is, the air is the only dielectric here. Okay, and the metallic part has been surrounding through to it. So the surrounding is the metal, the hollow metal core. Inside is a single conductor line. So these are known as the rectangular waveguides, circular waveguides. That are known as a single conductor lines. Okay, so they can be rectangular waveguides, circular waveguide, elliptical waveguide, single reached waveguides, double reached waveguides. Whenever you can see the waveguide, that has been known as the single conductor lines, right? So let us go to the third part. That's the open boundary structure. There are two open boundary structures. First of all, dielectric rods. So what are the dielectric rods and what are the open waveguides? We will certainly know at the end of this lecture. So let us go through to the conductor lines, the multi-conductor lines. As you can see, the transmission lines which has more than one conductor are known as or called as multi-conductor lines. And whether you can see, there is a coaxial line. Okay, for an example, we can take coaxial lines. This one is mostly used for high frequency applications. The coaxial line consists of inner conductor, inner diameter. Okay, go through to the internal structure. You will understand this. This is a basic structure of a coaxial line. Let us zoom this part to understand it. Now you can see the total thing inside. Okay, that's the thing. Okay, so this is how the insulator. So here you can see this is the insulator part, insulation. A central part is made of a highly conductive material, inner conductor, and the outer conductor is less conductive than the inner conductor. So between the dielectric and it has a dielectric constant, and the other two have the dielectric constants. So there is a diameter set here, that is the outer cladding diameter, that is the inner cladding diameter, and that's the total structure of the cross-sectional view of the coaxial lines. So as it is said that it has an inner conductor and there is an outer conductor outside, so it's known as a multi-conductor cable. Okay, so this type of transmission is particularly known as the TEM mode transmission. TEM means transverse electromagnetic mode. Okay, we will certainly know about the modes on the next lecture after this. Okay, so there is no cutoff frequency in the coaxial cable, but in waveguides you will get the cutoff frequency. It passes all frequencies. However, for higher frequencies, some higher order non-TEM mode starts propagating, causing a lot of attenuation. So it can go through any kind of frequency, but some higher frequencies you need to incorporate waveguides. Why? Because this type of conductive lines will go to attenuation, so we have to just make them to make a non-TEM mode TEM mode operation to just lessen the effect of attenuation. Now this is the strip lines. These are the planar transmission lines. So that means planar means it has a plane inside. There is a ground plane outer side, and there is a center conductor inside, as you can see, and there are two parts, two insulators are right there. So these are known as the strip lines. There is a center conductor, that is the strip. So the line has been known as a strip line. Okay, just because of changing the width of the strip, you can change the parameters, or you can change the electromagnetic wave propagations under the strip lines. So there are two insulator sides and two ground planes outside, and a simple center conductor inside. A conductor is just because of a strip, just because of a simple rectangular shape, very small, that has been incorporated on the structure. So a strip line consists of central thin conducting strip, which width omega, you can say W, is greater than its thickness T. It has a thickness of T, here thickness of the T. It is placed inside the low dielectric substrate of that is the substrate. Okay, where the strip is been placed. So two wide ground plates. There are two wide ground plates right there. So the width of the ground plates is 5 times greater than the spacing between the plates. The thickness of material, the thickness of metallic central conductor and the thickness of metallic ground planes are the same. So the thickness of the ground plane and thickness of the material are the same. Okay, that's all about the strip lines. Now going through to another examples, that is micro strip lines. Micro means the strip width is going to be very much thinner, so the thickness will be very much incorporated close to the micron level thickness. Okay, so that is known as the micro strip lines. So there is the same thing. There is a dielectric slab or substrate here, and there is a two ground plate right there. There is a conductor strip, same, but that is micro strip. That means it is designed for the micron level incorporations under the dielectric slab. Okay, there are some other lines too. There is a parallel strip line, there is a coplanar strip line. So a parallel strip line is going to surpass the TEM mode, and coplanar is strip line is formed by two conductors. They are same. So these are the conductor, the same material, same thing, same ideology, or same kind of method that they have been put onto it. The two conductors in the middle of the part is a dielectric, but in the strip lines there is a simple conductor that has been incorporated, or that has been covered by the dielectric, but here is in dielectric has been covered by the conductors. That is the parallel strip line. As you can see here, there is a coplanar strip line. There are coplanar strip line means there are two strip lines that has been just incorporated, or that has been formulated or fabricated parallel to each other. They are known as the coplanar strip lines. That's all for